Okay, so you may recognize this sheet. I gave it to you at the beginning of factoring to get you to start practicing the basics of factoring and getting the idea of splitting up a trinomial into its binomial factors. So here we have a warm-up, and they always usually do this to start you in the mindset of going, one direction, so that when we go back the other way, it won't be as new or confusing. So let's start here with 1 or x plus 1, x plus 5. So x times x squared. Hopefully by this point you're all getting to be champion multipliers. I noticed in your quizzes that you really didn't have a problem with multiplying. It was the adding and subtracting, and it was mostly because you were just so good at multiplying. You didn't want to not multiply. So here we come up with a 6x plus 5. And we can go back and look at how it's broken into different terms that give us this trinomial. All right, let's do the next one. So you can pause this, do it yourself, and then unpause it and check. Okay, so then we get m squared plus 6m minus 4m minus 24 m squared plus 2m minus 24, and then k squared minus 7k minus 3k plus 21, k squared minus 10k plus 21. So how did you do? Hopefully nailed it, right? So to factor a trinomial in the form of x squared plus bx plus c, we even call it ax squared, where just a is equal to 1, you must find two integers that, of course, add up to the b term and multiply to the c term. And I know this is a massive long blank, but that really is all it is. C term. All right. All right. So we're moving down into the body of the notes. And of course now my screen doesn't want to adjust. There we go. And we're asked what two integers have a product of 12 and a sum of 7. And this is where we're going to use the diamond concept. Or if you just want to use the x, that works fine. Where we put the middle term up top and the c term, the third term, there on the bottom. And we say, well, what two numbers when added will make 7 and multiplied make 12? Well, the answer to that, of course, is 4 and 3. So the integers are positive 4 and positive 3. And now we can write two binomials, x plus 4 and x plus 3, and then distribute to check. So we distribute x to x is x squared, x to 3 is 3x, x to 4 is 4x, and 4 to 3 is 12. And we combine like terms, and we get our original trinomial. Okay, so we've done all the ones in sets 1 and 2. So we're going to move on to sets 3 and 4. These are new to us. Feels like it's crooked. Looks like it's crooked. I can't figure out how to uncrooked it. So it'll just have to be crooked. Sorry with those of you guys that, let me see, try this. Oh, that did it. Had to hit a different button. Okay. Let's go back. Set 3, we're going to look at making our little x. And so we want a number that when added equals -2 and when multiplied makes a -3. So I'm thinking we try a -3 and a +1. And so we would get a minus 3 and a plus 1, which would give us a squared minus 3a plus a minus 3, which gives us a squared minus 2a minus 3. So I'll let you do those guys, and then let's just check on set 4. Again, we want two integers that will add up to negative 11, multiply to equal 24. Well, I'm thinking some kind of 8 and 3, right? We want this number to end up as a negative, so we need the bigger number to be negative. Oh no, we guess they both have to be negative because the product will be positive. So negative 8 times negative 3. Otherwise, the number would have to be bigger than 11 so that you would subtract it down to 11. Okay, so, sorry, it's getting late here when I'm making this. We get x minus 8 and x minus 3. X squared minus 8x minus 3x plus 24, which is equal to x squared minus 11x plus 24. So I'll let you work on set 4, and then there's mixed practice for you guys to work on. And we're going to look at examples with a GCF. So this is important because, again, the first step, and I told you I was going to say this over and over again, the first step is always to look for the GCF. Whether we remind you and tell you to do that or not, always look for a GCF. So what do each of these terms have in common? Well, they're all factorable by 4, which leaves you with k squared plus 3k plus 2. Now, do your diamond problem. We want them to multiply to 2, but add up to 3. How about 2 and 1? All right, so again, we got to keep the 4 out there and get k plus 2 and k plus 1. Okay, so how on earth am I ever going to multiply this the other way to check it? Well, PEMDAS, right? I mean, you're going to multiply, you can multiply that 4 times the middle two terms, and then you'll distribute those terms out, or you could just go back in reverse order, multiply your binomial, and then multiply it times the 4. So go ahead and work on these bottom 6. You want to pull out a GCF first. Come see me if you have any questions.